Okay. Hi guys, so if you can hear me clearly, this is the SS1000 at my background. Right now we're spinning, or we're going to be spinning PVDF for filtration applications. I want to explain to you the quality line production that the machine has after you spin. After you're spinning the solution, you have to ensure for us to ensure that there's proper homogeneity in the fabrication of the nanofiber membrane. We've actually set up a control test, or a suction cartridge, if you allow it, to measure the pressure difference of the membrane while it's being continuously moved along from the rotor roll. So you have a rotor roll system. From one end, there's a rotor roll. Okay, it comes out empty and it enters the chamber where there's spun jets, coating it consistently with nanofiber membranes. Once it gets coated, on the opposite end there is a control line test, a fan of cartridge that sucks pressure in and measures the pressure difference. So it accumulates that data into this control panel, and what we do is we actually set up a data plot here to determine, okay, how homogeneous, how well coatings being formed while we're continuing our production cycle. So we have a couple of values here, the coefficient of variation, and we determine, okay, how much of the value is changing for over time, and the less the coefficient of variation, the better it is, and the more homogeneous production we're enabling here. Enabling it right now, you see in real time the suction fan is actually measuring the pressure difference, and you can see how it varies over time. And you can see the values here. So the values that you see here, they're being plotted onto this graph. You'll see the red line is actually the line that measures the pressure difference, and this gray line is actually the position of the cartridge suction fan as it moves along laterally on the membrane. So yeah, this essentially covers the filtration control and how we produce nanofiber membranes for filtration media. Thank you. So let's see if we can get a better look at from the camera of how the operation is working. All right. So you notice here that you might be able to see that fan, the cartridge rather, moving from one end to the other as the roll to roll moves. So on one end you have this empty substrate that's moving and it's getting coated here. We haven't opened it yet, but just to give you an idea of how it works. So it's moving along, getting coated, and when it gets coated, it moves past this cartridge that has a funnel, or basically an orifice that applies the pressure, and it measures that pressure difference onto the control panel, as we mentioned before. Okay, now my colleague just helped me here. He just filled the solution on the surface of the spinneret, and we're going to be starting production soon. So first the feeders, the needles, the white Teflon needles, they insert the solution onto the surface, and then after it gets filled completely, we will activate the high voltage, and you'll be able to see some spun jets soon. So we can begin right now. See if here. First one. Let's begin. Negative. Okay, so I think we're gonna run 80 kilovolts right now to start the jets. Okay, so now we have started we've initiated the electrospinning process. You'll be able to see a lot of jets all along the line of the spinneret, and it goes to 3 different bars of spinneret. So it's getting coated, when we have properly stabilized the process, we'll go back to the graphs and show you how the pressure difference is changing now that we are coating our substrate. Okay, now we're adjusting the negative voltage, so the collector also, you can control its negative voltage to improve the electrostatic field strength. We have to be careful from there. All right, so plus here. All right, so now the coating process initiated. Let me see if we can show the screen. All right, so first of all, I'll go to the home page. to show you how it looks like, the process overall. So you have the home page here. It's showing the feeder. There's 40 seconds till it refills. You can adjust the timing for that if you would prefer. And we're operating at about 80 kilovolts positive spin rate and negative 11 for the collector. You might need to adjust that depending on the solution you have, and to prevent potential breakdowns of electrical breakdowns. We're operating at 20 millimeter. Okay, so the coding is occurring. Okay, I'm going to go to the pressure test area and go zoom in to give you a better look in short time. So what you're seeing here is now the funnel that we showed you, the cartridge before, moving from one end to the other. This is its plotting point, and the red line here is the pressure difference of the substrate. So you can see it's variating. So of course it's not possible to have a perfect straight line for your thin spinning. Okay, for your thin spinning, but you can see that it alternates very like literally from each other. Like it's not as of a big difference. So this is actually good for us. This indicates, okay, there's better distribution of the nanofibers, and they're being well made across the width of the substrate roll. So yeah, you can see right here it's actually changing from 18 to 20, 23. So the midpoint would be 20 mbar pressure. Of course, we can control the. I'm not going to change the value right now because it's perfect. But you can control the how far the cartridge is going to go from the substrate width. Okay, how far do you want it to go from its middle point? And you can control its speed, the stroking speed. So how fast do you want your funnel cartridge or suction pressure tester, whatever you want to call it, moving from one end to the other. So I think it's on a proper speed right now, 99 millimeters per second and 820 millimeters in width. Yeah, so this is essentially what we're doing right now for ensuring that there's a quality control for our nanofiber filters when they can go for air filtration and hopefully for processing for HVAC and similar applications. Right. So yeah, this essentially covers the whole process, and this is how you would normally want to set up a production line for nanofiber. You will need a couple of these machines, and you will have continuous production and also continuous quality check with the cartridge that we installed here. And this is something that's very important for production that you should be doing continuously, consistently. If you ever see a huge gap or a change, that indicates, okay, the operational parameters haven't been optimized, so it's back to the drawing board, and then you can readjust it. So it's a good measure, a good checking you have, rather than having cutting out the substrate and setting it for testing. This is basically you're getting the value right off the bat of, okay, how if our solution is working or not. So that basically all I had to say about it, and I think I covered most of it. All right, perfect. Yeah, so let me see if there's anything else. I think the process is it's a good idea to show the process again. So just to give you a small recap, from one end we fill the empty polyethylene substrate, okay, polyester, excuse me. It's moving slowly but surely in a roll-to-roll system, and as it moves, it enters the chamber where the high electric field is set up, and it's being coated by 3 spinnerets. And as it gets coated, at the end of the just before the collection roll-up area, we are measuring the pressure difference of the filter. So let's see here if we can show. If the camera can get a better look of the, yeah, I see. Okay, it's good. So yeah, it's moving from one end to the other. We set the distance to be 820 millimeters, and speed is 99, and it's continuously checking the pressure difference of the fab. Let me see if this is. So yeah, I think this gave you a good idea of the process here. We're actually feeding from one end to the other. Going back to control here. So just for this process, we've elected to keep one end to be the one that's actually filling the solution, the metal rod, and the other end is empty. So it just comes back to its initial point before refilling. There's about 60 seconds before it refills the solution. Of course, this depends on how conductive your solution is, how fast the jets are emitting. You might need to have a faster flow rate if your solution is actually has really high electrospinability and quickly depletes the spinneret. So yeah, so this is essentially the process here. You might notice where the solution is coming from. There's actually a tube channel going from that's entering the feeder here, and it actually leads all the way to the source tank where we've installed some peristaltic pumps that can help provide pressure. In some cases, you might have to, you might have to control the inside chamber. In which case, we have installed some heating units implemented here, and also dehumidifiers that you'll be able to see inside the machine. You can control from here. Basically, it's very similar to the graph that we mentioned. Right now, it's consistently stable because we haven't activated the heating unit or the dehumidifier yet. Because right now the spinning is perfect, but if you need to adjust or tune the ambience inside, you can do so by turning on the heater. Can go up to 40. So our target is 40 degrees Celsius, and humidity is 34. So now we've activated the dehumidifier and the temperature, and they're gonna increase the temperature to 40 where we set it, and reduce the humidity to 30 where we set it. So right now it takes time, but over time you'll notice that the graph will also show you the difference. So it's something to consider if you're using a solution that's hypersensitive to the chamber inside. I'll just turn this off right now because I don't want to change the spinning too much, because it's working just fine right now for PVDF. Let's see if we can show you another angle. You notice here the cartridge is actually moving. The roll is also moving. So what we're actually, it's consistently moving and trying to measure the pressure difference. Yeah, so yeah, this is basically it. I think if you notice that when I activated the atmosphere settings, let's see here, you don't want to open the chamber by any what. So it means you can also set it to a mode where if the door ever opens, the process will rather come to a halt. So I'm going to open this with the dehumidifier open. Now you might notice, okay, I have a dehumidifier on, but just opening the external, ambience room will just affect the value. And then you get your error right here, indicating that please close the doors. So it'll continue basically indicating, okay, that the door is open. There's external influence on the ambience inside, so please close the door. So there's some precaution that you have, like some options you have here, just to be sure. Let me turn off the humidity again. Like I wanted to stay at around 34%. So anyways, yeah, so that basically covers the SS spinner, especially for a production line for air filtration. Alternatively, so after all the process ends up, you have basically a large fabric roll. This can go in 1 meter in width. For this machine, you can go even higher, widths depending on what your production capacity, what your target production capacity is. But here for this machine, you'll have a width of 1 meter, and depending on the GSM of your substrate, like 2535 GSM, you can go up to several hundred, up to maybe even 1700 or roughly 2000 meters in linear length for one roll capacity. So you can have one roll that's completely treated with your filter function membrane, and you can utilize that for your product. And then you can, after that process done, you can load another large fabric roll and continue production. Get back here. Right. So this basically what I attempted to do here was to give you in brief, or as much as I can compactly provide the information about the SS1000, especially for air filtration. But I understand that you might have other applications, or you might have more questions. If that's the case, then I highly urge you to reach out to us at sales@inovenso.com, or if you have a technical question, maybe R&D service at inovenso.com, which we're and I will and my team and I will get back to you as soon as possible for whatever your question may be.